Welcome and hello. This is a video tutorial on HEC HMS, and in this lesson, I'm going to talk about subbasins, specifically the discretization methods. All right, seeing that this is the first video on subbasins, there will be a few others after it. I just wanted to first mention that subbasins are one of the primary hydrologic elements in a watershed. Their purpose is to convert precipitation to runoff, and there's lots of other details to discuss. So it's not that simple. All right. So anyway, this lesson is about discretization methods, and discretization is basically the process of subdividing a subbasin into multiple parts, simply because, say, the precipitation over a subbasin may not be equal in all places at all times. So in HMS, we assign gridded data to the subbasins to eventually create the results that we want. All right, so what I have here is a watershed. I've already zoomed in, but I'll zoom out again. I've subdivided this watershed into subbasins based on the hydrology and the watershed delineation. So there's subbasins, there's reaches. The outlet is in this northwest corner, so I'm going to zoom in over here. Go ahead and click on this first subbasin. This is subbasin 45 I've selected. You can see that over here in the Watershed Explorer. And then down below that in the components editor, let me make this a little bit wider. We have our different sub tabs within the components editor for that selected subbasin 45. There's subbasin, loss, transform, base flow, and options. So we're going to stick with this first subbasin tab, and this is where we select the discretization method. So right now it's set to none, and that's perfectly fine. You can have all your subbasins set to none, which is what they are to start because that's the default setting. And that would just basically treat the entire subbasin like one single homogeneous unit. The problem with none as the discretization method is it doesn't allow you to use many of the other methods associated with the subbasin. For instance, if you want to use the canopy method right here, you need to select the discretization method, structured, unstructured, or file specific. It just can't be none. Also, if you want to use a surface method or a loss method, which are here and here, we also need to specify a non-none discretization method. And lastly, for the transform method, if we want to use 2D diffusion wave or mod Clark, then those are two other situations where we need to define the discretization. The structured discretization method is the next one down on the list. So I'll go ahead and set that. It asks me if I'm sure I want to change it. I say yes. Then what happened is now I have a discretization tab here in my components editor. Let me make this a little bit wider so it's all in one row. Right. So the first tab is subbasin. Now the second tab is discretization. And my data is file, the projection, and the cell size. So for the projection, I have options for SHG or UTM. If I select UTM, I'd also have to specify which zone it is. But for this lesson, I'm just going to say SHG, and then the cell size ranges from 10 meters all the way up to 10,000 meters in a one side of a square-shaped grid. So I'm going to go ahead and just keep it with 2,000 meters. That's the default. And then I'm going to click Save. Now, if I actually want to see the grids on the screen and generate the grids, I need to go up to GIS and then Compute and then Grid Cells. So that ran. The reason I'm not seeing it yet is because I need to turn on the discretization layer. So go View, Map Layers, and then I have discretization right here. And now we see that the discretization layer is active and we see those cells that have been added there. If I want to change the cell size, for instance, maybe these cells are too large, I can do that. I'll just change it to say 1000 and then save. And then I will rerun that computation, grid cells. It takes a moment. And now you can see that the cell size has changed. We have more cells, but of course they are smaller in size. Let's go ahead and do the same thing for another subbasin. So I will select what is this, subbasin 44, and then we'll go discretization method structured, and then yes, discretization tab. Let's go ahead and go with 500 for our cell size and keep it with SHG. Save, and then let's just do one more. Let's do this one right here, subbasin 1. Okay, and then subbasin tab, discretization method structured, yes. And then let's change this to, let's go 100 and see what happens there. So we'll go save, and then we need to run the computation. It's running. And yeah, you can see that there's different sizes between 100, what was this, 500 and 1,000. I'm going to change this 100 to a 200. I believe that should look better. Then save and then compute. Okay, that looks good. In this discretization tab, we have this file here, and it's referencing a basin underscore one.sqlite file because this is basin one that I'm dealing with here. And the user's manual mentions not to touch this file. It's a read-only file, but that's not going to stop me because I'm curious. So I'm going to open up SQLite Studio. There's lots of different ways to access a SQLite database file. So just go ahead and open that file with whatever software you're using. Okay, I'm navigating to the file, and here it is, basin1 .sql. So I'll say okay. I don't know if I want that. Okay. Right, so I'm going to double click. Now here are the different tables. We have a table for discretization, the version. You can read the table names. The only tables that I found any interesting data, subbasin 2D. So this is the structure of the table itself. I'm interested in the data. And here we have the 45 subbasins listed out. So we've got the name, the centroid of the XY, area in square kilometers it looks like, and latitude and longitude, as well as a couple IDs. Okay, well, there's a few other tables. Not a lot to see. I'm not recommending going in here and changing anything. I just wanted to show that. All right, let's go ahead and go to the unstructured type of discretization method. So I'll select this basin 43, and then I'll select my subbasin subtab, and then unstructured, and then yes. I do not have a discretization subtab. I was having some problems with the unstructured discretization, so I'm going to tell you what the user's manual says, and then I'll figure out what's going on later. Unstructured grids are most commonly used with the 2D diffusion wave transform method, typically imported from a HEC-RAS unsteady plan HDF file. Spatial elements are a unstructured discretization. They're stored in an HDF file. So what the user's manual says about the unstructured discretization is you would have a discretization subtab with a file here. You'd reference the HDF file, and then there's also this other field for number of connections. And what it says is that the number of connections is the number of connections to or from the unstructured discretization. Connections are created during the import and currently cannot be modified by the user. Okay, next up is the file specified discretization. So I'll select the subbasin here and then come over to file specified. And then yes, I'm sure I want to make that change. File specified must provide the file path to the grid defining file. It's expected that a mod Clark grid cell file will be selected. So if I go to discretization, this is where you select the mod file. So I'll go ahead and navigate to that. But before I do, I wanted to mention that I can create these .mod files as well by going up to GIS, compute, and then create grid cell file. So I'm going to go ahead and select that. I'm just going to use these default settings of SHG projection and a 2000 meter cell size, and then click next. Then next it's asking me where I want to put that file, and we'll just put it in my project directory, call it basin1.mod, and then click finish. So that file is generating. Let's go ahead and check it out. Here is my lesson 15. This is my project directory. And then I have my basin_1.mod file that was just created. So let's go ahead and take a peek at that. And here is the file that it created. So we have for each subbasin, 12, 34, 11, and so on. What we have is some grid cell data. So we have data for each cell. Apparently it's X coordinate, Y coordinate, travel length, and area. So this is the contents of the .mod file that file specified discretization method is looking for. We would just go ahead and navigate to that file, and I'm not going to do it. The last thing I want to mention in this lesson is that so far we've just been looking at these subbasins one at a time, but it may be nice to get a global view and see all the different discretizations in one single viewing. And to do that, you can go up to parameters and then discretization and then select structured, sure. So this is selecting all of our structured type subbasins. We have subbasin 1, 44, and 45 with the file, projection, and the cell size. If, for instance, I wanted to change these to all be, say, 500, I can make global edits just by double clicking the cell size, changing the value, and then at the bottom, I'll click apply. So next time I run the compute, those new cell sizes will display on the grid. All right. Well, that was it for this lesson in subbasins. Specifically, we talked about the different discretization methods to create a discretization within each subbasin of the watershed here in HEC HMS.